at the end of last semester, we were doing matrices. And one of the most fascinating things I find about matrices is that if you know the vertices of a triangle, you can find the area of that triangle using a determinant. Remember the determinant with the slanted lines, the 3 lines going this way, the 3 lines going that way when you added the thing? Well, we're going to do the determinant on the calculator. Don't worry about having to do that again. But I just think, who figured this out and how does it work when I teach it to you? So I'm going to teach you 2 methods today on how to find the area of a triangle. But here are all the methods between now and pre-cal that you can find the area of a triangle. We're going to explore some of the other ones too, okay? And you're probably sometime next week, early next week, we'll have a little quiz where you have some triangles, maybe 2 or 3, and you've got to do them 2 or 3 different ways. Find the area 2 or 3 different ways. But for tonight, you're going to be doing it 2 ways, okay? Got it? So the first way is this triangle. We're going to turn this triangle into a rectangle, okay? So what I'm going to do, and watch me first, and then I'll let you draw it in. I'll stop recording. You can draw it in. But what you're going to do is you're going to bring from this point, go down to the level of that point, and then go all the way up to the level of that next point. And then you just come across. See how you're making a rectangle? You come down and you come across. And do you see that there's a rectangle around that blue triangle? Everybody see it? Go ahead and draw it. So if you notice, the 3 outside triangles, the ones that have the green sides to them, are right triangles, okay? And if you have a right triangle, all you have to do to find the area is you have to count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this side's 11. This side here is 3. This one down here is 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6, 7. That's a 7 by 7. Everybody see what I'm doing? And this one here is a 1, 2, 3, 4 by
1, 2, 3,
10.
10. Okay.
By 10. I want to find the area of this blue triangle, okay? So let's consider that like the shaded region of a picture. Well, I have a formula that's patented by me and copyrighted and everything. Nobody can publish this formula. And it's area of the shaded region equals area of the whole thing minus area of the hole or holes in the thing. So it's a hole minus a holes. Okay?
Oh, wow. That
All right.
was an ICT study.
Yes. So if I want what is the area of the whole rectangle, the whole green rectangle on the outside?
10 by times 11, so it'll be
110. Yes, 110, right? And now we have to take away the area of these 3 green regions. Everybody understand what I'm saying? So, so this top right-hand triangle right here, the 11 by 3, if you have a right triangle, to find the area, it's 1/2 base times height, and the base and the height are the 2 sides that are not the hypotenuse. You understand that? You remember that from geometry? So it's 1/2 of 33, which is 16.5. So this is 16.5 here. What would this one be down here? This 7 by 7 would be 1/2 of 49. Everybody see that? Which is 24.5. Because 7 times 7 is 49, and it's 1/2 base times height. Did you see what I did?
7 times 9 is 63, right?
The last one is 10 times 4, which is 40, divided by 2, which is 20. So now this is simple. It's going to be 110 minus 16.5 minus 24.5 minus 20, and then you find your total answer, which is what? What is 110 minus all those things? Sure you understand when you take the area of the whole thing, which is 110, and take away the 3 holes in the picture, which are those 3 green triangles, you will get the area of the shaded region. Doesn't it make sense? If the whole thing is a certain amount and you're taking away pieces of it, then what's left is what's shaded. Okay? Everybody understand how to do that? So that's method 1 you're doing for today. You're encasing the triangle in a rectangle, finding the area of the 3 triangles that creates, and subtracting it from the area of the whole rectangle. Got it? And that'll give you your thing. Then you're going to do this, and this is a weird one. And who figured this out is weird. So now you're going to do 1/2, and you're going to find the determinant. Well, what are we going to do here? And this is the very top formula in your formula sheet. And on this one, you could get a negative number. You just know it's positive because area is always positive. You're not going to have a negative area. But depending on how you put these points down, you might get a negative. Just ignore the negative, okay? So you're going to put the vertices right in a row. -1, -4, and this last column are going to be 1s. How that works, I have no idea. I have not analyzed why this works. And you're going to key that in as a matrix. Everybody key in -5, 6, 1, 6, 3, 1, -1, -4, 1. The last column are 1s. You put that in every problem you do. Go ahead and key it in. Both of them give you 49. So you've done it using the rectangle, and you've done it using the matrix, and you got the same answer. Well, guess what? When you do your homework, you should get the same answer when you do it both ways. Otherwise, something's wrong somewhere. So check your work, okay?